Our next speaker is Neil Mehltretter. Neil is a technical director for Kaeser and has 20 years of compressed air station design and auditing experience. Please join me in welcoming Neil.
Good afternoon, everyone. Thanks, Kimberly, and thanks, Andrew and Pascal. I think we've covered quite a lot of ground already. Today we're going to talk a little bit about Kaeser's offering with our smart sensors, but it's a good opportunity to talk about measuring and managing. And growing up in the industry, this is kind of what I did, living on data and trying to make system improvements. So this is a good opportunity to talk about those things as well. Okay, we have spent quite a bit of time talking about different types of sensors and locations of sensors. So thanks, Pascal, for bringing that up. Really, if you can't draw it, then you're not going to understand how the system is operating and really where you would want to measure. I think we covered this with Andrew, but it's a good opportunity to talk about what the big three are, and really that's pressure, flow, and power. And we saw a great example from Pascal of a single track or a double track of compressors with two dryers, and from there you can kind of understand where you might want to install your input data. Power is a very big thing, and obviously as we discussed earlier, you're going to want to have amps, power factor, and voltage in that measurement. And you can see down here on the Kaeser offering, there is what we call the energy analyzer for our Kaeser measurement technology. And that's going to do a multitude of things, as well as look at harmonics as such. This is great for compressors, as well as maybe dryers, or for really any type of rotating equipment, say vacuum screws or blowers as well. When it comes to operation, you're going to have measurements within the compressed air system. So that'll be your piping. So like we discussed already, you're talking about pressure and temperature maybe. Pressure dew point is also a big key item. As Pascal had mentioned in his presentation, gives you an indication of whether or not you're moving towards perhaps a situation where one of your dryers may have failed, or perhaps your desiccant needs to be replaced, and so on and so forth. So the key here for us is that there are multiple items that will bus out to the system, whether it be to the Kaeser master controller via Ethernet, or to the customer's interface or dashboard via Modbus. So, again, within the compressed air system, which would be your pressures, your flows, also at the compressor itself, or blower, vacuum screw, dryer with the energy analyzer, or even in the ambient. So the ambient, we kind of had that discussion, right, in regard to the ratings of compressor with Andrew, ACFM versus SCFM, and the ambient analyzer will help you determine that with atmospheric pressure, temperature, as well as relative humidity. And it'll give you some indications on how good or poorly the actual compressor room is performing, and also how your station is going to be performing as well. So what do you need to know? Pascal gave us a good indicator of sit down and figure out what your KPIs are. What are your key performance indicators? And then go about your measurement plan to figure out how to get those values back out. One thing that you may not be seeing is in regard to not recording information that's ongoing in regard to unplanned downtime. So if you are having those things occur right now, the question would be why. Certainly, compressor operation is a big indicator with that. And the sensors that we're talking about here with measurement technology may not be giving you that data directly. So we're talking really alarm indication, whether the unit's loaded or idling, whether the motor might be turning, things like this. If it's a variable frequency drive, variable speed drive, what is that operating frequency, or what is that output flow? Lower equipment performance, we talked a little bit about that too, about measuring the right information. So if we're only measuring a single leg of the amps and those amps are high, then we're going to be overestimating what that power consumption is, and then your specific power or your key performance indicator there is going to be really poor. Tracking and managing this information is going to be invaluable over time. And that kind of comes where the Kaeser Sigma Air Manager certainly could help, but also the dashboards that we looked at with Pascal and Andrew brought up as well. These are things that allow users to figure out how well or poorly a system is running over time. So from Kaeser's perspective, you know, it's a natural addition to add these types of sensors to our station design. It really supports our comprehensive approach. You know, what we want to provide is what customers need, not necessarily what customers want. And those are always hard conversations to have without data. With data, obviously a lot easier to say, okay, well, you know, maybe your budget is 200 horsepower and we want to split that between two 100 horsepower compressors, or most customers might be more indicative of one 200 horsepower VFD. And if we have the data, maybe that shows that we really only need 100 horsepower worth of compressed air. So, you know, these kind of sensors and this data and the streaming of that data really will help us figure out and pinpoint what customers really need in their system. It's going to help customers manage that compressed air asset and then hone in on what those costs are. We're using them today in our air over the fence applications, what we call Sigma Air Utilities, where Kaeser owns the equipment and then sells the compressed air as a cubic foot per minute. And we're also using them in our enclosures and skid builds as well. So this is a great opportunity for us to understand how those stations are running, and then also to control those stations a little bit better, like I mentioned with the, for example, the ambient sensor. So that can help us trigger opening and closing louvers or when recirculation is required. In the end, you know, over the course of time, since, you know, we've been in this industry for quite a long time, we've had many a customer come to us and say, we want this flow meter installed in your particular station. And this gives us an opportunity to offer something that customers actually have an interest in. And then that's fully integrated to our station versus, as Pascal had mentioned, the simple 4-to-20 with the Ethernet connectivity on the Sigma network. This will bus all the information that would be required or of interest to a customer. So how can you recoup these costs quickly? Definitely with improved reliability of equipment. We talked a little bit already about that room temperature, improved productivity in regard to air quality or pressure stability. So this is going to have that pressure dew point involved, or perhaps additional pressure sensors downstream, so we can try to balance that station. And, you know, in general, energy savings is always key, right? You know, Andrew mentioned how expensive it is to generate compressed air. So the bigger the system, the more important to measure energy-related parameters. Benefits, periodic assessments don't necessarily cover the dynamic nature of plant operations. And this is why, you know, when folks say, well, how much data should I pull from the site? I always ask, well, how much data do you have? Leak management, we're coming up on Memorial Day, which is a traditional holiday here in the US, and it's a good opportunity to find out what that leakage rate is, but if we weren't measuring a time frame like that, we might not see it. Other, you know, items here, you know, the big thing is to improve system performance, and if you're not measuring that system performance, then how can you improve it? So this gives you an opportunity, whether it's through the Kaeser sensors or any of the other sensors we talked about directly today, that it's really an opportunity for us to improve. So again, thank you everyone for your attention, and I'll yield back the time to Kimberly. I'm sure we have plenty of questions.